3,000 miles beneath our feet, a solid iron sphere the size of the moon is slowing down, reversing its relative path, and melting out of shape. This behavior contradicts the tidy cross-sections we learned in school. Those diagrams showed a static, perfectly spherical inner core, neatly encased in a liquid outer core, and a thick rocky mantle. But around 2010, researchers identified a sharp decline in the core's rotation speed. The core hasn't reversed its direction in space. Instead, it is moving slower than the Earth's surface. Because the mantle and crust are now outpacing it, the core appears to be slipping backward relative to us. This decoupling indicates that the heart of our world is no longer in sync with its outer layers, creating a central mystery at the very bottom of the planet. Since we cannot dig to the core, seismologists rely on repeating earthquakes. These are identical tremors that occur in the exact same location over decades, acting as a high-resolution scan of the Earth's interior. This diagram illustrates the paths researchers use to track these tremors. They measure exactly how long seismic waves take to travel from the South Sandwich Islands straight through the liquid and solid cores to receivers in Alaska. This graph displays two seismograms captured in 1967 and 1982. By overlaying the records, you can see a clear offset in the wave peaks, which confirms the inner core shifted position during that 15-year interval. To track this movement even further back, scientists analyzed data from Cold War-era nuclear tests. They used the massive seismic waves generated by Soviet detonations at Novaya Zemlya, along with repeating French and American tests. Compiling a half-century of this seismic data reveals that the inner core operates on an entirely independent rotational timeline from the surface. The inner core undergoes a multi-decadal oscillation, a cycle where its rotation speed swings back and forth over a roughly 70-year period. Two competing forces drive this cycle. The turbulent liquid outer core generates an electromagnetic torque, pushing the solid inner core to rotate faster. At the same time, the massive rocky mantle exerts a gravitational pull, acting as a brake to tether the iron sphere. This constant push and pull creates a pendulum effect. The inner core accelerates until it hits a gravitational limit, then slows down relative to the surface rotation. The center of our planet is a war zone between electromagnetism and gravity. If you're finding this deep dive into Earth's mechanics interesting, please like the video and subscribe. In 2025, University of Southern California researchers identified evidence that the inner core is not the rigid, solid sphere previously assumed. They detected viscous deformation, a process where the near surface of the inner core physically squishes and shifts under intense pressure and heat. This warping is caused by the liquid outer core. Its turbulence is so violent that it physically disrupts and remolds its solid neighbor. Seismic data collected between 1991 and 2024 reveals that these structural changes are occurring across decades, occurring on a human timescale. The inner core is a dynamic engine, constantly being battered and reshaped by the molten ocean surrounding it. The inner core functions as a fluid-driven system, its physical structure reacting to the turbulent liquid outer core. This physical shifting and deformation of the core directly influences the processes that generate Earth's thermal and magnetic fields. These changes in rotational momentum also alter the rotation of the entire planet, shifting the length of a day on the surface by fractions of a millisecond. While a mere thousandth of a second is lost in the noise of churning oceans and weather patterns, it confirms that the surface is physically linked to the deep interior. The tranquil surface we inhabit is physically linked to a shape-shifting, dancing core over 3,000 miles below.